Hello everyone. For section 10.5b here, we're going to continue looking at secant lines and segments. As you saw in the previous section and in the previous video, we were looking at the angle relationships that came from all of these secant lines and chords and whatnot and how they intersect the circle. So now for this half of the section, we explore the side lengths, what happens to the measurements of the lengths as opposed to the degrees and the angles that are created from. So we still have three possible scenarios with the sides. It's still the same idea. We could have two chords, or if they were full lines, secants, intersecting on the inside of the circle. We could have two secants that intersect somewhere outside the circle, or we could have a secant with a tangent line that intersect outside the circle here. Based on these three setups, we get a different calculation formula, if you want to call it that, for each one of them. For the ones that are inside the circle, we multiply the values that are on the same segment. So in this case, A times B has to be equal to C times D for the other one. For the ones that intersect outside the circle, we end up looking at taking the outside portion times the length of the whole thing. So if we take this top one that's got A and B in it, A is the outside portion times the whole thing, A plus B, to be equal to C is the outside portion times the whole thing, C plus D. And in a similar setup here with the tangent one, we'll do the B and C one first because it matches up to what we saw in type number 2. B is the outside portion times the whole length B plus C. The key is the tangent one. A is outside because it is tangent, but it is also its entire length. So we're going to have to multiply it by itself, which is why the tangent ones introduce a squared value. The tangent one squared equaling the other multiplication. Ultimately, for every problem, it's a matter of recognize which of these three situations you have in the picture and set up the appropriate algebra calculation based on them. Past that, there's nothing else to really do in these questions. So for the first two examples here, we're going to explore the interior one with plain old simple numbers and then one with a little more algebra work involved. For the first example here, we multiply things on the same chord or secant. So 14 times 15 has to be equal to 10 times x. So let's clean that up a little bit. 14 times 15 is 210, and 10 times x is literally just 10x. If we divide the 10 out, we'll find that our missing value of x is 21. Same idea, just a little more involved algebra because obviously there's a little more work going on in these expressions here. But it's the same setup, and that's the key element. Recognize the pattern of how it's designed. Don't worry about how heavy the algebra becomes as you go through it. So 14 times the 2x plus 1 should be equal to 18 times the 2x minus 5. It's still the same pattern. Multiply the things that are on the same segment. Now let's go distribute this out. 14 times both of these will become 28x plus 14, equaling 18 times both of these will become 36x minus 90. We'll subtract the 28x off, so 14 is now equal to 8x minus 90, and add the 90 over. 104 is equal to 8x. If we divide out our 8, our value of x comes out to be 13. The question asked us to figure out the length of TQ, so we will go plug that 13 back in and figure out the length of TQ. So T to Q was 2 times our value of x plus 1. If we double up 13, we get 26, plus the extra 1 on the end makes TQ a length of 27. But this is the same plan for all the examples in this section. Build the appropriate algebra based on what the picture looks like. So for our next pair of examples, Let's explore the second type here. What if you had two secant lines that intersected outside the circle? We're still going to do the same idea. The pattern for type 2, if you look back at the first page of notes you just took, you are looking at the outside portion multiplied times the length of the entire secant. So 8 times the whole thing, 8 plus 19, should be the same as 9 times the whole thing, 9 plus x. If you want to write it as x plus 9, that's perfectly fine. I just like to keep it in order because it's easier for students to see. We started at the intersection point. 8 is outside, 8 and 19, 9 is outside, 9 and x. It just makes it easier for everybody to see it, but you can obviously flip that around to x plus 9 if you want the algebra to look a certain way. Let's go distribute and multiply everything out. For the left side, it's pure calculation. Add the 8 and the 19 together and then multiply the result by 8. We get 216. Distributing the 9 gives me 81 plus 9x. If we subtract that 81 off, 135 is now equal to 9x. Dividing out the 9 provides me that x would be equal to 15. We're going to apply the same setup logic with the more complex expressions over here. It's still the same design though. So 12 is the outside portion times the whole thing. 12 plus x plus 8 equaling 15 is the outside portion times the whole thing. 15 plus x minus 1. Let's clean up inside the parentheses because thanks to adding these together, we do have a couple of like terms to put together. So 12 times x plus 20 for combining the 12 and the 8 together to equal 15 times x plus 14, combining the 15 and the minus 1 together. Now we'll go distribute out. 12 times both of these is 12x plus 240. 15 times both of these is 15x plus 210. If we subtract our 12x off, 240 is now equal to 3x plus 210. If we subtract our 210 off, 30 is equal to 3x, and that makes all of this large-looking algebra rather nice. Comes out to be that x is equal to 10. Just don't forget the question. We were asked to find the length of yz, so I'm going to go plug my value back into my expression. Yz was the value of x minus 1, and 10 minus 1 is simply 9. There's one more type left, one more situation, one more formula, however you want to phrase it, and that is the secant line with the tangent attached to it. Don't forget that the tangent portion is my squared portion. So since 24 is the tangent, 24 squared, if you think back to the first page, 24 is outside and is also at the same time the entire length of that segment, should be equal to the outside portion, 18, times the whole thing, 18 plus x. We'll go clean up the squared and distribute all simultaneously. 24 squared gives me 576. Distributing the 18 creates 324 plus 18x. If we subtract our 324 off, we end up with 252 is now equal to 18x. So if we divide the 18 out, we'll get that x is equal to 14. Same idea in the other one. We'll take the tangent portion, so 16 squared is equal to the outside part 8 times the whole thing, 8 plus 5x minus 1. And then we'll go clean up everything as we go. 16 squared is 256. Inside the parentheses, if we combine the 8 and the minus 1, we'll have 5x plus 7. Now if we distribute the 8 from the outside, we finally have a problem to solve. 256 is equal to 40x plus 56. Subtract the 56 off for 200 equaling 40x. and then divide the 40 out of the problem, we'll find that x is equal to 5. Just don't forget the question. We were asked to find the length of Pn, so we'll go plug our 5 back into our problem here. The length of Pn was 5 times our x minus 1. 5 times 5 provides me with 25, and minus the 1 makes the length of Pn 24 units long. Now there's only one more example to go over, and it's a variation on this tangent one. You'll notice in both example 5 and example 6, the tangent portion is just a number, 24 in this one, 16 in this one. What if the tangent part had your variable in it? And that's the last thing to go over here. So what if your variable portion was in the tangent part? Because you're going to end up having to square it. This is the one special case of this problem that gets a little more involved. The setup part, at least the beginning setup part, is still the same. This is the tangent portion, so we will take x plus 5 squared, and it is equal to the outside part 12 times the whole thing, 12 plus 15. So we have x plus 5 squared is equal to, if we add 12 and 15 together, that's 27, times the 12 in front of it comes out to be 324. Now the question becomes, we need to solve for x, but it's stuck inside the squared. I can't just take a square root. I mean, it'd be nice if I could, but there are, some problems are going to come out to decimal form, and you don't want that as the answer. We want to go find an exact number here. So we're going to have to actually work out the algebra. Off to the side here, x plus 5 squared is very literally x plus 5 times itself. You probably learned it as FOIL, but we'll go with what it actually is. It's the distribution property. X times both x and 5 creates x squared and 5x. 5 times both x and 5 creates another 5x and a 25. Combining these middle terms together makes my expression x squared plus 10x plus 25. So I have x squared plus 10x plus 25 is equal to 324. Now, unfortunately, I cannot solve a quadratic that's of this format unless it's equal to 0. So I am forced to subtract the 324 over to the other side and turn my problem into x squared plus 10x minus 299 equaling 0. Now it's a matter of, let's go find some factors that could make this work. So we're going to generate a factored form here. The first term, I need two values that multiply up to x squared. There's only one possibility for that. It has to be x times x. There's no way to get around that one. Now, what do I need for the numbers? According to this negative sign, they have to be different. So one of them's a plus, one of them's a minus. And since the middle term is positive, the bigger number that I get is going here. I need the positive, the plus to be bigger. I need the minus, the negative to be smaller. That way when they add together, it stays positive when I combine them. Now I am looking for two numbers that multiply. Sorry for that, everybody. That multiply up to 299 and also add up to 10. Grab a calculator and test them. You'll eventually find 23 and 13, at which point x plus 23 is 0, or x minus 13 is 0. And then x is equal to negative 23, or x is equal to 13. Since we are dealing with a value and a length, plugging in negative 23 wouldn't work. If I plugged in negative 23, my length would be negative, so that answer cannot be possible. X equals 13 is the only one that I want. That's everything for section 10.5b. If there's any questions while you start working on the assignment, make sure to ask your teacher, and see everybody in the next section.